Okay, in this lesson in Chapter 8 is about natural logs. We're going to go back to the irrational number e. So if you have log base e of x, this special type of logarithmic function we're going to call the natural log. We call this ln of x or natural log of x. So if you have the natural log of e, this is the same thing as writing log base e, because that's what natural log is, of e equals what? 1. That's 1 because e to the first power equals e. So log base e, we're going to rewrite as just natural log of x. So natural log, still the same properties still apply as properties of logarithms. So if you're going to write this as a single logarithm, this is the same thing as writing natural log of a is going to be your numerator because we're subtracting here, and b squared is going to be your denominator because there's a 2 out front, and then you're going to add it to 1/2 natural log of c. So natural log of c, you're adding it, so that's going to be in the numerator. So c to the 1/2 power is the same thing as the square root of c. So you could either write it as the square root of c or c to the 1/2 power. So this is writing it as a single logarithm. In this case, it's a natural log. Now to solve with involving natural logs, you're going to use e. So e and the natural log are inverses. So what you do is you're going to put e, you're going to exponentiate ln of 3x and use e as a base, and then you're going to exponentiate e, or 6 as well. So now you have e to the natural log of 3x equals e to the 6. So e and natural log are inverses, so they're going to cancel out. So now you're going to have 3x equals e to the 6, and then divide both sides by 3. This right here is an exact value. E is an irrational number, so you can put this in your calculator and approximate. So it's approximately equal to 134.48. So if I slide over here, so how that's working is the natural log and e cancel out. So natural log base e, and you're going to make e as the base over here. These cancel out. So now you have 4x minus 1 equals e to the 36th power. So to solve for x, you're going to add 1 and then divide by 4. So it's e to the 36th power plus 1 over 4. This is going to be a huge number, so I'm just going to leave it exact like this because e to the 36 is going to be a very large number. Because remember, e is almost 3, so 3 to the 26 is going to be a large number. And then number 4, e, natural log base e cancels out. This is e right here. These two are canceled out, so now I have t minus 1 squared equals e cubed. So I'm going to take the square root of both sides. So I'm going to have t minus 1 equals e cubed. And I'm going to add 1. Or the square root of e cubed. And then I'm going to add 1. So this is what t is, which t is approximately equal to 5.8. Now I didn't want to do, well, over here. And the number 5, I'm going to subtract 4, so e to the x over 4 equals 3. So to get rid of the e, I'm going to take the natural log of each side. So if you have natural log, get rid of it by doing e to each side. If you have e, get rid of it by doing the natural log, because the natural log of e cancels out. So now you have x over 4 equals natural log of 3. So multiply both sides by 4. So now you have x equals 4 natural log of 3. Oops, 5. Why did I do 5? This should be 5 all along. 5, 5, 5. Oops. Natural log of 3. So notice I didn't put, be careful, because notice that you don't put the 5 with the 3. Don't put the natural log of 15. Do the natural log of 3 times 5. That's different. So make sure you're careful about how you put that in your calculator. So this is approximately equal to 5.49. When you were born, your grandparents opened a savings account with an initial deposit of $1,000. On your 16th birthday, the account was worth $2,500. If the interest was compounded continuously, so that should ring that we needed to use per. What was the interest rate? So we know that we had an initial amount of 1,000. We don't know the initial rate, but we know it was in for 16 years. And we know that eventually it was 2,500. So this time we're given A and the initial amount and the time, so we have to solve for R. So what we're going to do is I would divide both sides by 1,000. So you get 2.5 equals e to the 16r. Now you have an e equation and you're solving for a variable in the exponent. So you're going to take the natural log of each side. So natural log of 2.5 equals natural log of e cancels out. So 16r, and then divide both sides by 16. So you do the natural log of 2.5 and then divide it by 16. So you're going to get about, r is 0.0573. So that's about 5.73%. So that was the interest. And then number 7, how long does it take your money to double if you invested at 8.3% compounded continuously? So you're doubling your investment. So we don't know what we started with. We don't know what we ended with. So I'm going to do 2. I'm just going to use 2 because we're doubling it. Let's pretend that we started out with 1. Let's make it easy. So either way, it would work if you put 500 and 250 right here. If you put 4,000 and 2,000, you're still going to get 1/2 when you solve. So how long? So we're looking for a time. So e to the 0.083 t. So 1/2 equals e to the 0.083 t. You're going to take the natural log of each side. These two cancel out. So your answer is going to be natural log of 1/2 divided by 0.083. And that's going to give you your time. Same with letter B. How long would it take to double your money? So you can just do 2 equals 1 times e to the 0.183 times t. So then you'll have 1/2 equals e to the 0.183 t. Take the natural log of each side. These two cancel out. And then divide natural log of 1/2, press enter, and divide it by 0.183. So y equals e to the x is this exponential function. Looks like this. And so what you're going to do is the y-intercept is 1 because it's 1 times e to the x. So y equals ln of x is the inverse of it. So you could think about graphing y equals e to the x. So let's make a table of x and y values. If x is -2, if x is -1, if x is 0, 1. So 0.135. This is approximate because e is irrational. 0.368. 1, 2.718. And then y equals ln of x is the inverse of it. So remember the inverse function, the x and y flip around. So it's going to be 0.135 and negative 2. Negative 1, 0, 1. 0 is going to be 1. This is going to be 0.368. This is going to be 2.718. So I'm going to make my graph right here. So my x's are all positive. So I'll go, let this be 1. Let this be 2. Could have been a little neater. And then I'm going to let this be negative 1, negative 2. So 0.135 and then negative 2 is right here. 0.368 and negative 1 is right here. 1, 0. 2.781 right here. So you can see that it has an asymptote at x equals 0, and it's just the inverse of y equals e to the x. Okay, number 9. A rocket booster for a spacecraft has a mass ratio of 15 and an exhaust velocity of 2.1 kilometers per second and a firing time of 30. So looking up in the book, see example 2 on page 471, you have this maximum velocity equation, and now you're going to plug in c, which is the exhaust velocity, which we know is 2.1, and r, which is the mass ratio, is 15. And the time is 30 seconds. So you're just going to evaluate that. So that is about 5.39, and your units are kilometers per second. Letter B, can the spacecraft achieve a stable orbit 300 kilometers above the Earth? Explain. So the book reads that you need to have a speed of 7.7 kilometers per second in order to achieve a stable orbit. So you can't, because 5.39 right here is less than 7.7 kilometers per second. And the last example, solve with a natural log. So just like you want to get the logarithm by itself, you need to get the natural log by itself. So you're going to add 1 to each side. So get natural log of 2x minus 7 squared equals 3.8. And then exponentiate each side or use e as the base. These cancel out. So you have 2x minus 7 squared equals e to the 3.8. And take the square root. So you'll get 2x minus 7 equals the square root of e to the 3.8. And then you're going to want to add 7 and then divide this quantity by 2 to get your answer and round. So just be careful with the order of operations.